Okay, now I want to give you some information about a parabola, and then we'll determine what the equation is of the parabola. For one thing, I want you to realize that if the vertex, sorry about that, if the vertex is the order pair -2, 3, that means that when you plug -2 into the x part, you should get 0. So that means the x part would be x plus 2, right? This is what you'd plug -2 in to get 0. You'd have to plug 3 into the y part to get 0, so that would be y minus 3. If you plug 3 in here, you get 0. So you notice that the number with the x here is the opposite of the number with the x here. This is negative, this is positive. And similarly, this is positive 3, so negative 3 goes with the y. So keep that in mind. Okay, so we have the vertex and we have the focus of this parabola. So it might be a good idea to kind of draw a picture here really quickly. And we may not have to graph the whole thing, but this could be helpful. So vertex is at -2, positive 2. So I'll label this with a V. The focus is at 0, 2, so I'll label that with F. Clearly the parabola is going to open to the right, so this is a horizontal parabola. So that means the equation is going to be something like y squared equals a number times x. However, this is if the vertex was at the origin, and it's not. So I need, because there's a -2 on the x, that means I'm going to have x plus 2. Since there's a positive 2 on the y, I'm going to use y minus 2. So my equation actually is going to be y minus 2 squared equals some number times x plus 2. So I just replace those and use this sort of shifted version. Now I just need my focal diameter here. Since the parabola is going to open this way, the focal diameter is 4 times this distance, which is 2. So my focal diameter is 8, that's going to go here. And it's in the positive direction. So this is going to be positive, not negative. If it opened to the left, that would be a -8. So there's the equation for the parabola that's described up here. Notice we didn't draw a nice pretty graph, we just got enough information to find the equation. Alright, here's another example. The vertex now is at the origin, so just to get a quick graph here, 0, 0, it opens downward and it passes through the point 4, -8, so maybe something like this, 4, -8. And that's all we know. Now, a common misconception is to assume that the focus is right here. But do not assume that, because your focal diameter is not necessarily right here, it's wherever that focus is. So we actually need to find that. So this equation is going to be something like, since it's vertical, it's going to be x squared equals some number times y, and the vertex is at the origin, so I'm not going to change my x and y, they're fine the way they are. I just have to figure out my focal diameter. So let's use I don't know, let's use capital F for focal diameter. All we know about this is that it passes through this point, where x is 4 and y is -8. Well, if we know those two values, we're going to substitute them into the equation, and then we're going to solve for the remaining part, f, the focal diameter. So if I plug in 4 for x, I get 4 squared equals f, which we don't know, we're trying to find, times y, which is -8. So 16 equals f times -8 is the same thing as -8 times f. Divide both sides by f, and we get -2. Thus the equation for this parabola is, plug -2 back in, so it's x squared equals -2y. And the focal diameter, of course, is positive 2, not -2. The reason the negative is here is because the parabola opens downward. Okay, so big lesson we learned here. If you're given a point on a graph, that means you can plug those values in for x and y into the equation. That's a major lesson, very useful in lots of situations. So we saw a shifted parabola, one where the vertex was not at the origin, and we saw a non-shifted parabola and how to handle if a point is given that's not necessarily the focus or the vertex.